So I'm going to run through very quickly a little bit of background. First, about Earth Economics. We've been around for about 13 years, and we're a nonprofit. We're based in the Seattle area, and we work primarily with government agencies and other NGOs. Our focus is really incubating ideas that come out of research and turning them into case studies that can demonstrate broad and impactful applications. And when I say broad, I mean being able to reproduce this on a broad scale, a scale that makes a difference. So I always like to start with kind of a reset. You know, what we don't count, we don't value. And what we don't value is lost, usually. So in our work, we've identified that there's really 3 key ingredients, and yes, it helps if you sugar them. Raised awareness. Raised awareness is the number one thing that we can do to impact decisions, our decision makers. When we speak the language of the business, when we talk in money terms, that resonates. And we need to be able to react in a timely manner to influence decisions. So the decisions are things like, you know, establishing conservation areas, doing restoration projects. And in the United States, we are working very hard to move development out of the floodplain. So those are the types of decisions that we are really focused on. And that's what we call shifting investment. We're talking about investing dollars to invest in conservation and restoration. So we're all familiar with this paper, this Catalyst paper. You know, when it came out, it was all about time efficacy, time efficiency, and cost efficiency. This was a way to, first of all, say, our ecosystem services are worth a lot. And it introduced benefit transfer as a way to communicate that. Well, that was in 1997. And since then, we've had a lot of experience applying benefit transfer. And we know now, unequivocally, that it speaks to decision makers. It is an accepted methodology. We just had a meeting with the former government accounting office. The chief of the GFAO in Washington, D.C., he grilled us for 2 days. And at the end of the 2 days, he said, you know what? This is the best we have, and it's economics. Economics is all about estimating. So we got the stamp of approval. It's also defendable, and I'll talk about how it can be defendable in just a moment. So I wanted to actually back up because Dolph, in the very beginning, I think it was Gretchen Daly's slide that was the flow of how we get to changing how investment is made. And we actually work on this a little bit differently. As we've heard repeatedly over the last 2 days, the importance of valuation is for what we call the aha moment, right? It's not to say this is the exact price of an ecosystem service, but it's to get the decision maker to say, wow, I never thought about a forest as providing flood protection, for example. So the first step in our process, we identify the ecosystem services. We always do this with the local stakeholders. And when I say local stakeholders, I'm talking about those people who are the provisioners of ecosystem services, or have the land that provisions ecosystem services. Value is the next step. Whoops. Value is the next step, which we're going to go into in detail. Mapping and modeling actually comes after valuing in our chain of events. And I'll talk about why in a second. Then we analyze and fund. So the identify is the what. The value is the why. Why do we do it? And then the modeling and mapping and analysis is really the how. So once we have the value, once we have the range of values, decision makers say, wow, okay, so if I make this this decision, one decision versus another decision, then I am essentially making an economic decision for my region or my community. And then we can get into mapping and modeling those. So what is actually happening on the landscape? And we had a great presentation this morning about that. But mapping and modeling is quite expensive. And when we talk about valuing, we can do a benefit transfer for under $10,000, often under $2,000. And I'll talk about that. And then, of course, funding is the result. So when we talk about benefit transfer, we always use this kind of analogy. A benefit transfer isn't setting a price for an ecosystem service. A benefit transfer valuation is an appraisal, is akin to an appraisal, similar to how we appraise houses, businesses, and even art. So I'm going to give you a couple case studies. I know you've heard about the Louisiana study, so I'm going to be really, really quick. With benefit transfer, we took a whole big stack of primary studies. We produced a report, and the result? The Army Corps of Engineers. Now, this is the office that is responsible for building bridges and maintaining levees and dikes and keeping commercial transport open on the Mississippi River, among many other things. This government agency said, wow, you know what? It makes sense to include the hurricane protection and flood protection values of the wetlands. And, oops, I think and the result, it was the first time ever that the government, the Army Corps, adopted multi-criteria analysis for their cost-benefit analysis. Now, this is an institution that is very traditional, very staunch. This is a huge, huge win. We're also working with FEMA. So for those of you who don't know, FEMA, they're responsible for dealing with things like this. This is Hurricane Katrina. FEMA is the United States Federal Management and Emergency Administration. So when somebody's house gets blown down, you know, I think FEMA is most famous for the trailers that it deploys, but it does all kinds of other things. Well, FEMA recognizes that they are paying people when there is a disaster and a house gets flooded out, for example, in the floodplain. They are paying people to rebuild in the floodplain at the same point and the same place because the numbers do not justify relocating the house. So in this case study, just in August, it was the first time that we provided ecosystem service values to FEMA for their online benefit cost analysis tool. So this is the tool. If I'm a business or a state government or a city government or an individual person, I go into this tool and I describe my emergency and I describe my financial conditions and I give my location and all of that information. And out of that becomes basically a check and a decision. Well, do we pay you to rebuild your house? Or do we pay you to move? We buy out your house and you move to another location. Most people choose to move to another location. They don't want to be flooded out over and over again. And by including ecosystem service values, we are able to justify the cost to relocate them. Moving out of the United States, another real quick example is in Ecuador. We worked in the Yasuni International Park. This was a benefit transfer analysis. It resulted in a rapid assessment, resulted in the creation of a United Nations funding mechanism to leave Ecuador's largest oil reserves in the ground. Very exciting. And again, if we go back to timeliness, efficiency, and raised awareness, those are the things that really go into making these big things happen. So Dolph did a great job on the kind of the introduction. I think we have the same genesis with Bob and Rule and the University of Vermont. Our databases diverged shortly after 1998, but the initial database was an Excel spreadsheet. In 2008, by then we had hundreds of values, and we had completed about 10 valuations using benefit transfer. Sometimes we do original calculations, primary studies, but very rarely. And an ESP takes about a year to complete. So if we think about those big decisions, it takes about a year to get there still. In 2010, we introduced pivot sheets into the Excel database. It's pretty complex now. And this is just 2 years later, and now the average time to complete an ESP is 2.5 months. That's enough time to affect a lot of decisions. And we are working, this is the background and impetus for why we are moving our internal tools to the web to influence more decisions. So we have ported our database to a cloud database infrastructure, and we call it Simple Effective Resource for Valuing Ecosystem Services. And I like to say, and to the power of X is how many decisions we will be able to affect. We have built data models, and we're in the process of validating those data models with a temporary user interface, a UI. The UI allows us to test and to also show it to stakeholders and get their feedback on the kinds of things that they want without spending significant development time and investment. So the serves interface, we have actually 2 interfaces for serves. The first is really focused on internal Earth economic staff, our colleagues, being you, watershed managers, land conservancies, government agencies, academics. We get a lot of requests from environmental engineering consultants, more and more around the globe. And they're wanting us to do a quick evaluation, a rapid assessment to plug into their project for a city park or whatever, to make their project stronger. And we want to remove ourselves from that process and let them actually use the values, generate the values themselves. On the back end, we will be developing an API scope and publishing it as a draft. This is an application program interface that allows the data in serves to be rendered in another UI, in another user interface. So all of these different systems are using, to some degree, GIS information. So we can actually publish how to access the serves database so that these other software tools can actually access the data and render them in their own user interface. Okay, so I'm almost done here. I'm just going to focus a little bit on what the design goals of serves are, and then I think we can take a couple of questions. So it's really focused on the user at this point. We understand the data models. We have a lot of hard questions. We are working right now on currency conversion and inflation conversion. Those are very, very hard questions. And if you would like to participate in helping to figure this out, I invite you to contact me or even to review it. So we are we're working on many hard problems on the back end. But what we really want to do is make this tool very usable. And this is why we have not invested more than a couple $100 at this point into developing a user interface, because the user interface is really, really key to understanding how we're going to use it. We want it to be a global database. So my background is software engineering, and on the team we have several software engineers. And we know that it is very, very easy, if it's designed right, to build software in a way that it can be localized very easily. By localization, I mean you can go in and you can say, I want it in Spanish, I want it in Dutch, I want it in German, I want it in French. And that makes it very local. Talked about data conversion. So we'll do that data conversion automatically on the back end. it's very, very important that it's scalable to different types of applications. So we talk about biomes. At Earth Economics, a lot of times we deal with regions and land cover type combinations. We also want to have the database be flexible enough to do a sectoral analysis. What this means is you could select a region and then you could do an analysis looking at mining or forestry or agriculture or ecotourism. And then we wanted to also be able to work on the project level. Integrated auditing. So if we are going to have this tool be available and accessible on the back end with the API, and the federal government is going to connect to it, then we need to have very, very tight security. And so we are designing it to be SAS 70 and ISO compliant, and have transaction auditing similar to an accounting system. Business intelligence is a way that we can pay attention to how users are using the system. Business intelligence is kind of an art in software engineering. You can code the software to pay attention to use and develop trend analysis for usage. We can also use business intelligence to identify study gaps, as this is a growing and evolving database. And I've already talked about the back end. Project goals, this is kind of on the project side, very, very quickly. We want to have strong collaboration with the folks in this room, with ESP. We're partners in ESP, to make sure that the database and the taxonomies and the classifications that we use are all compatible, and you know, imagine. I mean, how many of you have taken and read a valuation study, a primary valuation study? Raise your hand. And how many of you have tried to take that valuation study and put it into a database? Raise your hand. Okay, so there's a few of us. And so the folks that raise their hand know that it can take anywhere from a day to 4 weeks. It's really, really hard to take studies that don't have common variables or they don't have the GIS data explicitly stated and merge them into a GIS-specific database. So one of the things that we envision is, imagine now, if we're able to folks want to publish in a database, they know that they can provide a summary table that does the conversions for us, that provides the GIS information, and so that stuff does not need to be what we call grokked out. So, self-sustaining business model. This is really, really important because there have been other ecosystem service databases. And one of the things that we have experienced with the ESD, we used to, anytime anybody called us and said, hey, give us a copy of your database, we said, sure, here it is. And then we realized we were getting into the business of technical support and trying to explain how the proper way and the not proper way. So I applaud your thinking about building that into the ESP UI. The other thing is, you know, these databases, they come and they go because they're not self-sustaining. So we're looking at a business model that is a service model, a pay-for-service model that allows collaborators to do in-kind service. So that means that if you participate in the database, reviewing studies, etc., as an academic or as a professional, then your fee for the service is just participating in the database. But if you're using it like a government agency or maybe for a class, then there's a service. We're working that out. And of course, we are gathering the best-in-class software team. We're based in Seattle, so we're very fortunate to have Real Networks and Google and Microsoft and Amazon, all resources right at our fingertips. And that's all I have to say.
to quick questions and then we go to the next speaker. Yes?
Thank you for your presentation. This is for both you and Sander. Would you be able, as a user, to find your own search queries through the API?
Yes, yeah. So if you would like a demo of the tool, I'd be happy to show it to you. What you would do is you go in and you actually create a scenario. So there's a couple of steps. You select a region, and the region can be a set of studies that could be by biome, or it's applicable to, it could be a local area. You can actually, as a user, as an economist user, you can define the region, and then within that region, you can create a series of scenarios. So for the folks that we work with, it's often the case that we need to start with a baseline valuation, and then we do a scenario. So scenario A could be we restore 100%. Scenario B, we restore 50% and turn the other 50% into ag/floodplain. You know, scenario C, so it allows you to very quickly create scenarios without having to start over.
To use something like Dropboxes.
Yes, absolutely. And then you can go back and retrieve your scenario.
But you won't provide an opportunity to define your own search query.
Yes, you can define your own search query. You can select by land cover type, land cover specific, which is, I think, subtype was Sanders' terminology, and then ecosystem service and ecosystem service specific. And you can select that way. You can select by study, and you basically create a grouping of studies, and you save that as a subset, either as a region or as a subset, and then you build your scenarios off of that.
What I meant was you use a relational database, I guess.
Yes, we use a relational database. It's a cloud-based service, yes.
But you cannot make your own SQL queries, like select star from...
You will be able to do it programmatically through the API.
Yeah, okay.
Yes.
But not, you cannot input...
No, we can't, because that's not SAS 70 compliant.
No, exactly.
Yeah.
Okay.